Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which will be helpful for the international entrance or any competitive exam you are preparing for. In addition to this, India level JEE Advanced and JEE Mains, which are helpful for IIT entrance and NIT entrance examinations, and Telangana, Andhra Pradesh MSET examination, which will pave the way for engineering stream, NEET chemistry for medicinal entrance exam throughout India. So in addition to all these, if you are aspiring for any government entrance exam, any government competitive examinations, in that case, general science paper will be there. There, the content what we are discussing will be very much helpful. Let's enter into our today's session. Name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per the IUPAC, what will be the name of these many compounds? All are commonly containing CO, which is called carbonyl, and moreover, it is called a ketonic functional group. Okay, here any carbonyl compound is designated as RC double bond O, R or H will be there. Okay, so here C double bond O will be common in a carbonyl compounds. For these carbonyl compounds, we have to assign name as per the IUPAC protocols. Let's see how can we name them. If this is the case, CH3, C double bond O, CH3 will be there. Alkane root word can be taken as a propane. Here 3 carbon, so that you can mention as a propane. And as per the IUPAC, general representation for these compounds will be alkanone. Okay, alkanone means this is the carbonyl ketone. So the ketone can be represented as a one, as a what? So if it is the main functional group, we have to pronounce it as the one. Okay, so this can be represented as a alkanone, right? So if any other main functional group is there, if this is becoming a side chain, that means substituent, at that condition you have to say oxo. So this ketone can be designated as oxo, but in all these cases, ketone itself, it is the main functional group, so that we can say what? It is alkanone. Generally, we can say alkanone, right? So being it is the 3 carbon chain, so parent chain will be 3 carbon, so that let me mention propanone. 3 carbon is represented as propanone. I need not to mention the position of this what C double bond O group, where it is located, need not to mention, because in ketone minimum carbon chain is 3 only, no? So less than 3 carbon, we can't construct the ketones. It is the simplest ketone. We can pronounce, generally we can say acetone. This is called acetone solvent, regarded as an organic solvent. Okay, but as per IUPAC, it is regarded as a propanone. And move on to another, where you can see one CH2 got increased. Whenever any two compounds which differs by CH2, this is called homologous series, right? CH3 C double bond O, CH2 CH3 is a 4 carbon parent chain, and you can mention as a butane. So in this butane, 4 carbons will be there, and moreover, ketone is located on the second carbon. So alkanone is the general representation. So that let me mention butanone. Need not to mention again 2-butanone, because either ketone may present on this carbon or in the on this carbon as well. Both are 2-butanone only, because whenever CO is there on this carbon, and this CH2 carbon, what happens? So you can start numbering from this right hand side, so that either of the side is fine. So if CO is there on this carbon, again it can be regarded as a 2-butanone only, because you can start numbering from this end, because least numbering is most preferable. So that butanone is the IUPAC name for this compound number 2. If you move on to another, where again you can find a difference of CH2 in between. Here also one more CH2 you can locate, so that both are said to be homologous series again. And here this is said to be symmetrical ketone. What is mean by symmetrical and asymmetrical ketone? So ketone, if contains both the sides a similar extent of alkyl chain length, that is said to be symmetrical nature. If you see the compound number 2, one side ethyl, in either side methyl is there, that is n-symmetrical. And in the third compound, both the sides you can find ethyl only, so that we can say it is the symmetrical ketone. This side ethyl is there, this side is also ethyl is there. Symmetrical ketone. We have to put a number for this ketone because there is a provision to locate this ketone either on the second or else the third carbon. That's the reason why. Let me mention 3-pentanone, being it is the 5-carbon parent chain. So alkane will be regarded as a pentane, and in order to locate IUPAC name for the entire compound, 3-pentanone will be the name, because ketone is located on the third carbon, no, so that 3-pentanone is the name for the given compound. What IUPAC is saying, IUPAC rule for this ketonic functional main functional group: if ketone is present in the given organic compound, you can remove this E from alkane and you can add on, so that we can pronounce it as a alkanone. The compound is pronounced as a alkanone. Okay, this is the name given by the IUPAC nomenclature. And these many compounds, let me segregate once again. Compound number 1 can be treated as 2-propanone and 2-butanone, and this will be 3-pentanone. For question number 1, here this is the way we can answer, and the general representation will be alkanone, right? Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. Here, give the name of the process that is used. Okay, so some industrial application part is provided over here to produce ammonia from nitrogen. Okay, in order to synthesize ammonia from nitrogen, we have multiple methods. Okay, so here so many methods are there. Any one method we can mention over here. And second is about to separate nitrogen from the liquid air. Okay, so air is the abundant quantity. So wherever you see air is available, no, around you, wherever you go, air is abundantly available, so that it is obvious, it is very essential to collect nitrogen from the air, because maximum extent of nitrogen only present, around 70% composition of air will be nitrogen only, so that it is the best method to separate the nitrogen from the air. So this is also another question we have to solve. Let's see how can we solve these two questions. Produce ammonia from nitrogen. Everybody aware about Haber's method is there for the synthesis of ammonia, and that is most important for the fertilizer. Everybody aware? For the plant growth, the essential elements are NPK, nitrogen, phosphorus, and potassium. Among nitrogen that is given in the form of urea, and that can be synthesized the same method. Okay, so that is the way we can go for the ammonia synthesis, which is very essential in the field of industrial synthesis of ammonia. So here this is another advanced method is provided: electrochemical synthesis. Electrochemical synthesis of ammonia stands for what? We are applying electrical current and chemical reaction got carried on the nitrogen, so that ammonia synthesis will be possible. Being it is a kind of simple reduction, nitrogen is the N2 diatomic molecule, where you can go for addition of hydrogen by electrochemical process. By applying the electrical current, chemical reaction is proceeded, so that ammonia formation is possible, and we are applying very mild conditions in order to synthesize. Conditions are very mild, so that environmental friendly conditions are apted over here. And this is the entire chart in order to synthesize ammonia from this nitrogen gas. Nitrogen reduction. So simply we can say it is the kind of reduction reaction. So in order to reduce the nitrogen, suitable reactor can be taken. The device where the reaction carried is called a reactor simply. And the electrolyte can be added. Electrolyte is a kind of solvent medium which used to dissociate into corresponding ions. That is said to be electrolyte. Being electrolysis process, electrolyte is very essential in order to mobilize, make a medium in order to get the reaction over its surface. So, and Another requirement is electrocatalyst. Electrocatalyst denotes what? In order to perform the electrochemical reaction, there should be a reaction fastener. So that is also required, which is called a catalyst. Catalyst can enhance the rate of reaction without participating in that reaction. So these many requirements we have, and there are certain kind of conditions we need to follow in order to reduce nitrogen into ammonia. So the reaction condition, optimal temperature is required, pH to be properly maintained. Being ammonia is a kind of basic, so that basic pH is required condition over here, and water medium can be taken as a electrolyte, aqueous conditions we are applying. And next is about cation, anion. So what cations are generated, and being electrolysis process, it is obvious to get ionic charges within the container. And how extent nitrogen is soluble, as everybody aware, nitrogen is somewhat inert in nature, so that it is required to enhance its solubility, so that rate of reaction got enhanced. That is also requirement. Ammonia detection, how extent ammonia synthesis is carried, what will be the rate of reaction in order to manufacture. The detection is also important from time to time. What mechanism they are following. So during the chemical reaction, what will be the mechanism they are adopting, that is also important to detect. And composition, how extent the starting materials we are taking, and what extent product composition we are getting, and what will be the kind of impurities generated in addition to the expected product, that composition also monitored. And the structure of the reactants and products to be analyzed. And supports. So supporting devices are required. Proper infrastructure is very essential in order to carry the reaction in a smooth manner. And size of the particles. So here, not only the reactants and the products, catalyst like that, diameter matters over here. As the diameter decreases, surface area increases, rate of reaction increases, so that size also matters for the rate of reaction. Loading process, how can we load the reactants in order to achieve the product in a short span of time, that also important. Conductivity, so here the environment should be in a better way in order to conduct the electricity in the maximum extent, so that we can achieve the product in a expected yield, right? Morphology, what texture they have, so what morphology they are exhibiting, based on that also the kind of reaction proceeds. If you are taking morphology of what a raw type of material, or else a solid type of material, or else liquid type of material, or else smaller diameter, larger diameter, all dimensions, what dimensions, in what dimension it is reacting is said to be its morphology, right? That also matters for the expected outcome of the product. And orientation denotes what, in which direction the reaction is proceeded, that is said to be orientation. So if proper synchronization is there in between the reactant, then only extent of reaction will be maximum and the product obtained in the maximum yield. Resistance, if you're considering about conductivity, resistance also matters. Okay, reciprocal of resistant is said to be conductivity. That's why if conductivity consider, resistance obviously taken into the consideration. And next is about ammonia collection. Being ammonia is the output of the entire reaction, so that in what way we are collecting and what extent that will be generated is also analyzed. Nitrogen mass transfer, in what way nitrogen got converted into the product. So mass transfer also we need to analyze, we need to understand about that one. Pressure, temperature, pH, these said to be a reaction conditions. Optimum pressure we need to maintain, what requirement, what suitable pressure, by changing, so by treating the same reaction in different under different pressure conditions, at what pressure reaction is maximum extent, that is called its optimization. In the similar manner, we can screen for temperature and pH of the medium as well. This is the way entire conditions are very essential in order to convert nitrogen into ammonia by means of reduction process. And the process carried is electrochemical synthesis, right? This is about question number A, to produce ammonia from nitrogen. Move on to second one. Second method is said to be, we are going to separate nitrogen from air, right? So nitrogen, what is the first of all we have to know what is the requirement of this nitrogen, why we have to take this nitrogen, why we need this nitrogen, then we will go for the separation of nitrogen from the air. Nitrogen is very essential not only for the plant species but also for the all living organisms. How can we say nitrogen is very essential? So nitrogen is the part of proteins in the living organisms, right? Proteins are very essential, which are called building blocks of human organisms or else any living organisms. In the same way, plants also require nitrogen in the maximum extent. That's why we are giving fertilizer like urea, ammonium sulfate, ammonium phosphate. Such fertilizers are provided, right? That's the reason why nitrogen is essential. So many fields we can use nitrogen. In addition, nitrogen also used in the refrigeration process, right? So liquid nitrogen, if taken, it used to provide around minus 198 degrees centigrade. That's the reason why refrigeration and cold storage go downs are devices where we can store grains and also any kind of seeds like that. Such a storage device is also equipped with the liquid nitrogen. And even in what we can say pharmaceutical industries, nitrogen is very essential because nitrogen able to generate the inert atmosphere. That way also nitrogen will be helpful in the industries. Uh, Whenever nitrogen atmosphere is there, the reaction will be carried in a smooth way, which will not react with any surrounding air conditions, right? So that inert atmosphere can be provided with the nitrogen. Multiple application we can get with the nitrogen. That's the reason why nitrogen is very essential in multiple ways, right? Now what we are doing, we are going to separate this nitrogen from the air. Why we are choosing air as the starting material means air is the mixture of gases. Air is said to be homogeneous. Homogeneous in the sense we can't separate what gases are. For example, in your surroundings, so many gases are present. Can you locate where nitrogen is there, where oxygen is there, where carbon dioxide? That's why all are together mixed in a proper composition. That is said to be a homogeneous mixture. We can't separate them, right? Air is the mixture of all the gases including nitrogen, oxygen, carbon dioxide. Noble gases also present in traces, right? So among all, around 70% composition contribution by nitrogen, 78% contribution by nitrogen only, right? So that nitrogen can be conveniently separated from the air. Okay, so let's see how it is possible, right? In order to achieve this nitrogen separation from the air, two methods will be provided. Among all, one method is said to be fractional distillation. What exactly fractional distillation? Fractional distillation is nothing but whatever composition is there in air, different components are there. All the components are not having equal melting point values, equal boiling point values. Based on their difference in the boiling point values, we can separate their fractions, which is called fractional distillation. By applying the device called fractional distillator, different fragments can be collected. Nitrogen can be collected at particular temperature zone. And next is about what oxygen can be collected in any other zone of temperature, carbon dioxide, and noble gases also located. Uh, Organ, all these noble gases also present in the air. That's the reason why fractional distillation is the best method in order to separate the fractions or gaseous components whichever present in the air. Especially liquefied nitrogen can be collected around the temperature of minus 198. That is nothing but by rounding up, it will be minus 200 degrees centigrade. This is the way fractional distillation will helpful for the separation of nitrogen. And another one will be at the correct low temperature. Low temperature is very essential in order to separate. So that low temperature is around minus 200 degrees centigrade. And whenever that liquid nitrogen got separated, which can be harvested, can find a larger extent of applications, especially in the industrial fields. Okay, so liquid form can be converted into either gas form. Either in the liquid form or gas form can be transported and can be stored in cylinders. And what in the what medical field we can apply this nitrogen. So hospitals we can use nitrogen atmosphere, and even in the industries and the chemical synthesis research we can use them. A refrigeration purpose we are using, and manufacturing, the maximum extent of application is for the synthesis of fertilizer. Fertilizers are very essential to grow the croplands. So in that case also nitrogen is the starting material. This is the way we can go for the separation of nitrogen. So by this, question number 2 is completed. Produce ammonia from nitrogen and separate the nitrogen from air. Both the questions, I think, properly answered. Move on to question number 3. Question number 3 is collected from JEE Advanced 2023 question paper, recent one. Among I3 positive, silicon O4 minus 4, SO2 Cl2, xenon F2, SO4, ClF3, nickel tetracarbonyl, xenon O2 F2, platinum Cl4 minus 2, xenon F4, SOCl2. The total number of species having sp3 hybridized central atoms are is, how many are there, we have to locate. These many are there. Multiple compounds are provided to you. So among all these compounds which are accompanied by sp3 hybridization, we have to identify how many number of species are there, we have to identify. Let's search one by one. So let's go with the analysis of one by one. First of all, we will consider I3 minus. So whenever I3 minus or I3 plus molecule, I3 plus is the bent molecule, I3 minus is a linear molecule. Here the hybridization is a kind of sp3d. Whenever sp3d hybridization will be there, so it will be a trigonal bipyramidal geometry. Trigonal bipyramidal geometry with the 3 lone pair of electrons will be there. So this is the kind of molecule you can notice where sp3 hybridization is not there, rather you can find sp3d hybridization. This is not possible. Move on to another molecule said to be SiO4 minus 4. SiO4 minus 4 you can see here. So it is the kind of silicate. So silicate, and being it is a sheet silicate. Why we are saying sheet silicate? Because they are appearing like a sheets. If in this molecule sheet silicate, 3 oxygen atoms of tetrahedral geometry will be there. They shared with the adjacent SO4 minus 4 tetrahedrons. You can clearly see here. Here sheet type of molecules are repeated. Okay, so its general geometry is located over here. SiO4, oxygens are 4 and each oxygen is accompanied by -1 charge. Overall SiO4 taken -4 will be there. So, and it is represented in the octahedral geometry. Whatever species octahedral geometry, obviously you can say sp3 hybridization. This SiO4 -4 is saying I'm sp3 hybridization. So it will count number 1. So how many are there? We are searching for that. So that first one we located. Move on to another. This is called SO2 Cl2. This SO2 Cl2 geometry is provided over here. Here sulfur is accompanied with the 2 double bond O, oxygens and 2 singly bonded chlorides will be there. Double bonded oxygens, single bonded chlorides will be there, and that is located as a perfect tetrahedral geometry. You can clearly see it is the tetrahedral geometry. That's the reason why SO2 Cl2 is a kind of I2 have sp3 hybridization, and it is counted for number 2, so that it is obvious to get sp3 hybridization in this molecule. Move on to third molecule called xenon difluoride. If you see the xenon difluoride, it is a kind of linear molecule and accompanied by 3 lone pair of electrons in this plane. So all three electron pairs are located in the plane, and it is said to be trigonal bipyramidal geometry. Linear shape will be there, and we can say sp3d hybridization. This will not count for sp3 hybridization. Move on to another molecule called SA4. If SA4 is a case, SA4 is the molecule taken into the consideration. So 4 covalently bonded fluorides are there, but the sulfur is also accompanied with one of the lone pair of electron upon that. Whenever lone pair of electron is there along with 4 singly bonded, we can simply say sp3d hybridization is possible for the given molecule. sp3d hybridization is clearly mentioned for SA4 molecule. So here sulfur is of 3s2 3p4 oxygen family element. 3s2 3p4 is the valency shell configuration. Let's excite the electrons into the outer shell so that one of the electron got excited, and you can locate like this. sp3d hybridization is clearly visible, and one of the orbital is having lone pair. That lone pair is located on the sulfur like this. Remaining four electrons got bonded with the fluorine atoms with SF4 molecule. sp3d hybridization is possible, so that we can't count it. Another molecule is called ClF3. ClF3 is also the kind of trigonal bipyramidal geometry. Chlorine is accompanied with the three covalent bonds, two lone pair of electrons, and it is acquiring T shape. Exact T shape will be there, and two lone pair of electrons are occupying equatorial position. Equatorial position occupied with the lone pair of electrons. One axial, above axial, below axial fluorides are there, and within the plane, one of the fluorine is located, so that it is a perfect T shape, and the geometry will be trigonal bipyramidal, so that we can clearly say sp3d hybridization. So 5 bonds if present, sp3d hybridization is the a condition over here. So move on to another molecule, that is nickel tetracarbonyl. Nickel tetracarbonyl perfectly tetrahedral in nature. All carbonyl ligands occupying corners of the tetrahedron. Four carbonyls are occupying corners of the tetrahedron, and central metal is located, and the set of four ligands are located in the tetrahedral geometry. So that this nickel tetracarbonyl is saying I too have sp3 hybridization, and it is counted for number 3. And you can clearly see 3d10 if electrons are moving there. 3d10 configuration you can see, and 4s to 4p6 sp3 hybridization. So here 4 ligands, 4 carbonyls are giving 2 electrons, so that 8 electrons total. sp3 hybridization you can clearly see here. So move on to another molecule called xenon F2O2. Xenon F2O2 molecule, this is a Lewis dot structure is provided. Central xenon is surrounded with the set of 2 fluorines and 2 oxygens. Oxygens bonded with the doubly bonded covalent bond, and fluorines with the single bonded covalent bonds. One of the lone pair is also accompanied around the xenon. And we can clearly say it is the kind of sp3d hybridization, trigonal bipyramidal geometry. This also not count for sp3 hybridization. Move on to another, platinum Cl4 minus 2. Platinum Cl4 minus 2 is participating in dsp2 hybridization. So everybody aware that platinum and palladium complexes all are square planar. Whatever the platinum compound, whatever the palladium compound, most of the copper complexes are square planar in nature. So that we can say platinum Cl4 minus 2 is the kind of square planar. Being it is a square planar, you can clearly say dsp2 hybridization will be there. Okay, so it is mentioned with this dsp2 hybridization. One of the d orbital, s orbital, two p orbitals got mixed up, and dsp2 hybridization, which will give square planar geometry. It is also not account for sp3 hybridization. Another molecule is taken into the consideration is xenon tetrafluoride. Whenever xenon tetrafluoride is there, 4 bonds are there, but 2 lone pair of electrons are there. 4 bonds are occupying the planar geometry, and 2 axial bonds are included with the lone pair of electrons. This is simply called sp3d2 hybridization. sp3d2 hybridization accounts for the octahedral geometry and square planar shape. Okay, so that it is also not the part of sp3 hybridization, it is the part of sp3d2 hybridization, right? So another molecule called SOCl2. SOCl2 is called what? Thionyl chloride. SOCl2 is called thionyl chloride. Let's see, thionyl chloride is having sulfur surrounded with the double bond O, and 2 chlorides will be there. One of the lone pair is also located. If lone pair also occupying the corner of tetrahedron, it will be simply represented by the tetrahedral geometry. You can locate like this. Tetrahedral geometry accounts for the sp3 hybridization. Hence, thionyl chloride is saying I too have sp3 hybridization, and it counts for the number 4. So this is the way what tetrahedral geometry will be there. If lone pair of electrons location is excluded, and it will contain the trigonal pyramidal shape. So molecular dimension is pyramidal, molecular geometry is the tetrahedral. So this is about what thionyl chloride. It also the part of sp3 hybridization, right? So all got segregated in one page. So whatever molecules are acquiring sp3 hybridization, these many are there. How many? 4 are there. One is SiO4 minus 4. Second is SO2 Cl2. Third is nickel tetracarbonyl. Fourth is SOCl2. These many are occupying sp3 hybridization, and you can clearly see tetrahedral geometry is there. By this, question number 3 is completed. We are moving to question number 4. Consider the following molecules. Br3O8. Br3O8 molecule is there. F2O is there. H2S4O6 is there. H2S5O6 is there. C3O2 is there. So these are the compounds having all are the part of what inorganic molecules only, and simply we can say all are oxides. Oxides of non-metals. All these are not a metals. Bromine is not a metal, fluorine is not a metal, sulfur is not the metal, sulfur is not the metal, carbon is not the metal. Non-metal oxides, we can clearly say all these are part of non-metal oxides. So the question is, they count number of atoms existing in their zero oxidation state in each molecule. How many of these molecules are having zero oxidation state? And in that molecule also, how many atoms are requiring zero oxidation state? We have to count. So oxidation number denotes what? Whatever charge present, that may be positive charge or negative charge acquired by the individual atoms in the given molecule, is said to be its oxidation number. Okay, if neutral molecule is there, number of positive charges should compensate number of negative charges. How many positive charges are there? Those many negative charges should be present, then only entire molecule will become what? Neutral in nature. If cation is there, positive charges should be larger than the negative charges. If anion is there, negative charges are greater than the positive charges. This is the way we can categorize. But all the molecules provided are neutral in nature, means no charges there on these molecules. And moreover, we can say all these are non-metal oxides. We have to analyze which of the elements, which of the atoms are having zero oxidation numbers in that. For that purpose, first of all, we are taking Br3O8. This is the answer collected from the topper. Br3O8, when considered, it can exist in BrO3, BrO2, BrO3 like this. This is the way we can locate that. And Br3O8, you can clearly see this is the way all the bromine atoms are acquiring the charge. Being bromine surrounded with the 3 oxygens, so that let's locate each oxygen accounts for the -2 charge, and the left the balance counterbalanced with the +6 charge on the bromine. This is the way bromine is acquiring +6. And the second bromine is accompanied by 2 oxygens. Each oxygen accounts for -2. So the total -4 charge can be compensated with +4 on this bromine. Central bromine oxidation state will be +4. And move on to this terminal bromine, where 3 oxygens are there, each oxygen -2. So the total -6 charge is there, counterbalanced with the +6. This is the way bromine +6, bromine +4, bromine +6. This is the way we can locate their oxidation number. And move on to any other OF2 molecule. If OF2 is the case, what happens? Always the fundamental thing is, as per the Mulliken scale, fluoride is the highest electronegative element in the entire periodic table. That's the reason why it will not acquire positive charge by any chance, and no other charge is there except -1. That is the fundamental thing you can notice. So that fluorine can acquire -1 always. There is no other question for that. So that in OF2 molecule, 2 fluorines are there. So that -1 for one fluorine, -1 for second fluorine, total -2 charge. To compensate -2, this oxygen, central oxygen is accompanied with the +2 oxidation state. Okay, oxygen generally -2 only, but whenever it is in combination with the fluorine, oxygen is acquiring positive, fluorine is acquiring negative, so that no atom is existing in zero. Fluorine is acquiring -1, oxygen is getting +2, so that we can't say there is no choice for zero oxidation number for this molecule. Move on to H2S4O6. The molecule is represented like this. H2 means 2 hydrogens are there. S4, how many sulfurs are required? 1, 2, 3, 4 sulfurs are required. How many oxygens are there? 1, 2, 3, 4, 5, 6. H2, S4, O6. This is the molecule we are considering. In this molecule, this sulfur is accompanied by 2 oxygens, so that -2, -2. Whenever OH is there, OH will not give -2, rather OH always -1 only. Hydroxide, if you consider, hydroxide always account for -1 charge, so that this sulfur is gaining how many? So -2, -2, total -4 plus -1, -5 charges for oxygens, counterbalanced with the +5 charge and the central sulfur. Oxidation state of this central sulfur will be +5. And here also you can locate the same one. Whenever sulfur is there, accompanied with the double bond O and OH, here also +5. How we calculated here, same can be applied over here as well, right? So here, whenever these two sulfur direct linkage is the kind of thioether linkage, we can say. Sulfur bonded linkage is called thioether linkage, right? And there is no any oxygen, no other polarizing group is there, so that we can locate 0, 0. So 0, 0 is found. So the question is, which of the elements are acquiring zero oxidation number in the given compound? Here we found how many? So this molecule is saying I have 2 zero oxidation numbers, one sulfur and second sulfur, both are having 0. That's why 2 atoms are acquiring 0 oxidation number. So for this we solved oxidation number and move on to another. Whenever S5, H2S5O6, what molecule it is? H2 S5O6 is the molecule. Whenever sulfur with a double bond OH is there, just now we calculated +5 will be the oxidation state around the central sulfur. And the same is applied for this terminal sulfur also. Whenever the another sulfur linkages, these are called what? Thioether linkages, no? Earlier we got only 2 sulfur, but here we got 3 sulfur linkages. All sulfurs are not accompanied with any oxygen. That's why you can put 0, 0, 0 on them, so that this molecule is saying I have 3. So this molecule is having 3 atoms accompanied with the 0 oxidation number, right? This is the way we can answer. Here also you found a 0 oxidation number. And one more molecule we are considering, that is a carbon. How many carbons are there? 1, 2, 3, C3. And how many oxygens are there? 2 oxygens, C3O2. Whenever C3O2 is the case, C3O2 is the molecule. So it is all the atoms are bonded with double bonds only. So this is called what? Cumulative double bonds. If adjacent double bonds are located, this is the system called cumulative double bonds. Whenever cumulative double bonds are present, we can locate like this. Wherever the carbon is just adjacent to the oxygen is acquiring +2, because oxygen is -2, right? Immediate carbon is acquiring +2. Here also same case. This terminal carbon is also having contact with oxygen, so that here also you can put +2. Okay, so but here whatever central oxygen is there, oxidation state will become 0, because there is no contact with any oxygen, no atom around that, so that we can say here you can find a 0. So what this molecule is saying, C3O2 is saying I have 1 atom with the 0 oxidation number, right? This is the way we can answer. So entire molecules are segregated over here. Whenever B3O, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. Br3O8 when taken, no atom is having 0. So that it may not be the correct answer. When OF2 molecule taken, -1 plus 2 is there, it is not also correct answer. When H2, S4, O6 is taken into the consideration, 2 atoms are acquiring 0 oxidation number. And whenever H2, S5, O6 considered, 3 atoms are acquiring the oxidation number 0. And when C3O2 taken, 1 carbon is acquiring 0 oxidation number. This is the way we can answer the given question, right? Move on to question number 5. This is the question collected from the Gurukulam Degree College lecturer entrance examination, competitive examination. From that, the question is collected. Trans platinum L2Cl2. So this is a kind of a square planar complex, and it is located as a trans complex. Trans means what? Similar functional groups are in the opposite directions, which is called a trans isomer. Cis isomer, similar functional groups are in the same side. Okay. Whenever trans platinum L2Cl2 is treated with Y minus, here what happens? Substitution will carried. Y minus will be added. One of the chloride will be removed. This is called what? A substitution. What will be the correct order of ligand substitution reaction to enter into this complex? What kind of substitution is more favorable? This is clearly explained by trans effect. So among all, ROH is least having least ability to react, and next level will be chloride, next level will be nitro, next level will be thiocyanato, right? So this is about the right order. Highest reactivity is accounted for SCN, and NO2 will be the next level, chloride, and least is given for ROH minus. It is clearly mentioned in the electrochemical series, spectrochemical series, and these many ligands are provided where you can locate OH minus first, later on chloride, later on SCN, later on NO2. This is the way we can answer the question. The right order will be ROH. OH is first located only in the one option, least is only located in the one option, so from that only we can clearly sort out the correct answer. What is the correct answer? We can clearly sort out this based on what? Their strength of the ligand. You can participate in the substitution reaction in this kind of coordination compounds. It is the question given from inorganic chemistry and moreover coordination compounds. Okay, so last question of the session, question number 6. How many bridged carbonyls are present in iridium 4 CO taken 12? It is the question given from organometallic compounds. This is a kind of metal complex, and which is in combination with carbonyls, metal carbonyls we can say. This is a part of metal carbonyls. Metal carbonyls having multiple applications in the field. That's why the study about metal carbonyls are highly extensive. Here the compound provided is iridium 4 CO taken 12. Whenever this is the compound taken, they are asking for how many bridged carbonyls are there. Bridged carbonyl is nothing but which is connecting two iridium molecules. In between two iridiums, if carbonyl is there as a bridge, then we can say that is the bridged carbonyl. How many are there? We have to identify. The answer will be 0. Let's see how can we answer 0. Whenever iridium 4 CO taken 12 is taken, this geometry is considered. So all the iridium molecules are like tetrahedral geometry, and each iridium is accompanied by 3 carbonyls. 3 carbonyls like this. Let me count. 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12. 12 carbonyls, all 12 carbonyls are terminal carbonyls only. They are not located in between the iridium. Can you find any carbonyls in between the iridium? Not possible. So that let me mention 0 bridged carbonyls are there in iridium 4 CO taken 12. This is called what? A metal carbonyl compound where bridged carbonyls are 0. So by this, we extensively studied about the content whichever collected for the day, and hope the session will be very much informative and helpful for your further preparation and give the zeal for further continuation of the preparation. I'm sincerely requesting you to like the channel and comment which part is really interesting for you, and share with the aspirants who are seriously preparing for any kind of examination, and subscribe the channel in order to receive more such kind of updates in the near future. Thank you very much for your patient listening. Thank you, one and all.